Betelgeuse, a colossal red star, located at the outer reaches of our cosmic neighborhood, is a wonder of the galaxy. If it were placed where the Sun is, its size would extend to the orbit of Jupiter. This immense, unpredictable giant is poised for an explosion of unimaginable proportions. Prepare yourself for an event of galactic significance. Betelgeuse, the red supergiant star on the periphery of our solar system, is sending out alarming signals across the vast expanse of space. Astronomers have uncovered something unsettling about this massive star using the James Webb Space Telescope. Renowned scientist Brian Cox has issued a warning. The pressing question is whether we are on the brink of witnessing a cosmic detonation that will alter the night sky forever. The mystery of Betelgeuse exists within the infinite vastness of the universe. Stars are born, live, and perish in extraordinary ways. Recently, one star has attracted both the attention and concern of astronomers and the public: Betelgeuse, a red supergiant star in the constellation Orion. It's enormously massive and ancient, with its distinctive reddish hue and fluctuating brilliance having long captivated observers. Recent developments have heightened interest in this enormous entity, and as we learn more about Betelgeuse, we may be approaching a pivotal moment in its life cycle. But what do these changes signify? Are we seeing the early stages of a cosmic spectacle of unimaginable scale? Betelgeuse's enormous size and its life cycle are key elements in understanding its significance. This star is approximately 1,000 times the size of our Sun, making its magnitude nearly beyond comprehension. Imagine a star so large that if it replaced the Sun, its surface would reach beyond the orbit of Mars, encompassing Mercury, Venus, Earth, and Mars. This vast size not only demonstrates Betelgeuse's remarkable scale, but also reveals its current position in the stellar life cycle. As a red supergiant, Betelgeuse is nearing its dramatic end, expanding and cooling after exhausting its hydrogen fuel and fusing helium. Betelgeuse is estimated to be between 8 and 8.5 million years old. Although this is relatively young by human standards, it is ancient in cosmic terms. Over millions of years, Betelgeuse has undergone dramatic transformations, evolving from a hot blue star into the red giant we observe today. It is now in the final stage of its life as a red supergiant. Stars like Betelgeuse experience profound changes over their lifetimes due to the continuous forces of atomic fusion and gravity. A key feature of Betelgeuse's current phase is its reddish color. This color arises from its cooler surface temperature compared to stars like our Sun. Its brightness fluctuates, and historical records show that the Sun's surface temperature is around 5,500 K, while Betelgeuse's surface temperature is much cooler, around 3,500 K. This cooler temperature causes Betelgeuse to emit light at wavelengths that give it a red appearance, reflecting the ongoing processes within the star's massive gaseous structure. The fact that Betelgeuse's color has shifted over time adds an additional layer of intrigue. Ancient records, including those from Roman and Chinese civilizations, suggest that Betelgeuse was yellow as recently as 1,000 years ago. By the 9th century, Arabic astronomers began noting its red hue. This change in color over the centuries signifies the star's evolution. An intriguing aspect of Betelgeuse is its fluctuating brightness. It is a semi-regular variable star, meaning its luminosity varies periodically. These cycles of dimming and brightening have fascinated astronomers for centuries. Typically, Betelgeuse undergoes multi-day cycles and longer 5-year cycles. As early as 1836, Sir John Herschel recorded these variations, and Native American oral traditions may date back even further. However, what makes Betelgeuse particularly puzzling is the inconsistency of these brightness changes. Unlike many stars that exhibit predictable fluctuations in brightness, Betelgeuse sometimes deviates from this pattern, suggesting complex and not fully understood processes inside its immense structure. In recent years, astronomers were stunned by a sudden and dramatic change in Betelgeuse's appearance. This unprecedented darkening event sparked various theories. Known as the Great Dimming, it occurred in late 2019 when Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, began to fade mysteriously. The dimming occurred so rapidly that Betelgeuse's light was decreasing at a rate of 0.01 magnitudes per day. By February 2020, the star was at its dimmest. Oddly, Betelgeuse, which is typically visible to the naked eye even in areas with significant light pollution, became faint, and even casual observers could notice the difference. The mystery of the time delay complicates our understanding of Betelgeuse's behavior. Light from the star takes approximately 725 years to reach Earth. Therefore, when we observe Betelgeuse, we are seeing it as it appeared over 7 centuries ago, not as it is now. This time lag makes it difficult to predict and monitor rapid changes in its behavior. Andrea Dupree, the director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely tracked Betelgeuse's cosmic activity as part of a 3-year study to observe changes in the star's outer atmosphere. They used the Hubble Space Telescope to study the star, providing new insights into the nature of variable stars. Variable stars like Betelgeuse grow and shrink constantly, causing fluctuations in their brightness. Thanks to Hubble's sensitivity to ultraviolet light, astronomers were able to observe the layers above Betelgeuse's surface, heated by the star's swirling convection cells. Spectroscopic data gathered from Hubble in 2019 and 2020 revealed significant changes in Betelgeuse's upper atmosphere. The spectra primarily showed magnesium, indicating that material was being ejected from the star's surface into space at speeds of about 200,000 miles per hour. This eruption and mass loss continued for several months, with material traveling thousands of miles from the star, creating a dust cloud that obscured Betelgeuse's light. Dupree and her team found that the amount of material ejected from Betelgeuse's southern hemisphere was twice as much as expected. While it's typical for stars to lose mass over time, Betelgeuse's mass loss was occurring at a rate much faster than the Sun's. Astronomers speculated whether this event could signal the impending supernova of Betelgeuse. Given the star's size and the massive ejection of material, along with the dimming, scientists wondered if this could be an early sign of an explosive end. At 725 light-years away, any explosion from Betelgeuse would be visible from Earth, presenting a unique opportunity to study a supernova up close. The question remains, what does this dimming mean for Betelgeuse's future? Is it the precursor to an inevitable supernova? Or is it merely a temporary event in the star's long and complex life? Several theories have been proposed to explain the rapid dimming. One popular theory suggests that this could be an early stage in the supernova process, a signal that Betelgeuse is nearing the end of its life. Another theory proposes that dust, possibly ejected by the star itself, could be blocking our view. Red supergiants like Betelgeuse often shed material, which can accumulate into a dust cloud thick enough to obscure the star's light. A third theory suggests that changes in the star's photosphere, its apparent outer layer, could be responsible for the dimming. Spectroscopic investigations indicated that Betelgeuse's effective temperature had decreased by at least 170 K during the darkening, supporting the idea of significant changes on its surface. The Hubble Space Telescope played a crucial role in unraveling the mystery. Its observations showed that the dimming was likely due to a large amount of hot material being expelled into space. This material formed a dust cloud, blocking light from about a quarter of the star's surface. The dust cloud was made up of plasma, which traveled from Betelgeuse's hot atmosphere to cooler outer layers, forming dust grains that obstructed light. The impact of this ejected material was clearly evident from Hubble's ultraviolet light spectroscopic data, which began in January 2019. These observations provided vital information about the material traveling through the star's atmosphere long before the dimming occurred. Several ground-based telescopes also noticed the decline in brightness starting in December 2019, which Hubble confirmed and provided further details on. The realization that Betelgeuse was losing material at a faster rate than previously thought has important implications for our understanding of stellar evolution, especially for red supergiants. It's crucial to note that Betelgeuse isn't the only star undergoing such dramatic changes. Other historical supernovae, such as SN 1054 and SN 1987A, have offered valuable insights into the death of stars and the formation of new elements. If Betelgeuse eventually becomes a supernova, it would provide a spectacular light show visible from Earth. The explosion would be brighter than the moon and could even be seen during the day. This event would offer an unprecedented opportunity to study the final stages of a massive star's life and the spread of heavy elements across the universe. However, the distance between Betelgeuse and Earth ensures that any such explosion would not directly harm our planet. In conclusion, the ongoing observations of Betelgeuse's potential transformation will continue to deepen our understanding of stellar evolution and cosmic phenomena. Red supergiants like Betelgeuse play a crucial role in the life cycle of stars, and their explosive deaths contribute to the formation of heavy elements that are essential for the creation of planets and life. Studying stars like Betelgeuse offers profound insights into the end stages of stellar development and the processes that shape our universe.